We are looking at Module 5, Lesson 1 today, and we've been studying atoms and elements. Now it's time to talk about how they are organized, because there are roughly 120 of them. There's got to be a way to put them all together. So you probably already know that the elements are organized on the periodic table, but how were they put up there and what's the reason for putting them the way that they are? We just used the periodic table to do the electron configurations, so we should already know heading into this module that there are a lot of patterns to the periodic table and a lot of things that are true about the atoms themselves with how they're arranged on that table. They are sorted into their groups based on their properties. If you are an element and you are in a group, which is the vertical columns, remember? The up and down columns on the periodic table, they share the same properties. Now, as you go from left to right across the table, those characteristics vary greatly from one end to the other. So anything that is in the same group will behave in a similar way. So for example, let me skip over here to some periodic tables. Like here's one. So for example, with this, if you have hydrogen as your example, and I wanted to know what is something that acts similar to hydrogen, you pick anything out of that same column, out of that same group. You could answer it with lithium, sodium, potassium, rubidium, cesium, or francium. So keep that in mind when asked questions. From left to right, that doesn't work at all. Okay, so coming back over here, the periodic table itself was designed by Mendeleev. Mendeleev is a Russian scientist. Several other people attempted to make a table before him, but they really couldn't predict new elements that were found. In other words, like when something new was discovered, it wouldn't fit into the table that they had arranged. And Mendeleev was able to make a table where, it says right here, they were arranged by periodic law, where there's a repetition of their physical and chemical properties. Basically, every 8 elements is how often the properties repeat. And so he didn't know all the elements at the point that he did this. And so he left holes in the table. And in those holes, when new elements were discovered, they fit exactly what he thought would go in that particular gap. And so he was the one that he got to do the table. He got to do the periodic table. There's many other periodic tables than what we have today. So if you want to do a quick Google search, you can find all kinds of crazy things. Now let's talk about the table itself. There's 3 basic groups of elements. You can see them listed. I don't think most of this needs explanation from me. You should already know the words as well. In Module 2, we discussed the meanings of ductile and malleable. So you could pause this and take note of it. I'm not going to sit here and speak about things that you can quite frankly just read for yourself. I am, however, going to use this lovely periodic table here to show you where those elements lie. All right, let's just start with this bolded black line right here. This bolded black line refers to the metalloids. So I am going to kind of draw in green right here who the metalloids are, because we use them as our dividing line. You have a periodic table that I gave you in your notes. I thought that you would like to write some of these things on that periodic table, or some of the notes. I would prefer that if you have a hard copy of your reference table that you keep it blank, simply because when you take the final exam, you don't get to take it with a color-coded, notes written everywhere table. It's just a blank table, and you should be familiar with how to do that. So these green elements right here, these are the metalloids. Oftentimes acetine is included as well. The only thing that is not metalloid that is touching this line, I call this line the stair step. The only thing that's not a metalloid that's touching the stair step is aluminum. Aluminum is most definitely a metal. So in green, we did our metalloids. And the reason that I did them first is because, like I said, they are the dividing line. Now we'll see how easily it's going to let me change colors today. In blue, that is everything to the left of the stair step. Aluminum, gallium, tin, and bismuth, all of that to the left. It also includes these down here. So the metals are in blue. And, well, I'm quite sure you have already figured out then what's missing, which is the non-metals over here. We'll shade them in red. That's carbon, phosphorus, selenium, iodine, and radon. All of those and to the right are non-metals. So part of what I put in the notes earlier was that metals make up the majority of the periodic table, and, well, I mean, that's pretty clear if you look at it here. Everything to the left of the stair step. Something else to note about this, there are 2 elements on here that are liquids, and they are the only 2 elements on the entire periodic table that are liquids. Mercury is one of those, and bromine is the other one. It would kind of be worth knowing that. We did say in the notes that metals are mostly solids. They're almost all solids at room temperature except for mercury. And then non-metals, they're a little bit of everything. There's the one liquid. About half of them are solids and the other half are gases, so it's kind of a mixed boat. But there are only 2 liquids at room temperature. That's not a lot. Okay, so now we also need to know the family names. So what I'm going to do is I'm going to take another periodic table over here, and I'm going to label the families on this periodic table. I would suggest that you label the families on your own periodic table so that you could study with it. So maybe I'll label the families. I was going to switch and not use yellow, but, hey, there we go. All right. So right here, column number 1, all of column number 1. This right here, 1A, this is the alkali metals. They are all crazy reactive, especially in water. This is a highly reactive group of metals right here. They are so reactive that they do not exist in nature by themselves. They exist in nature as a compound because it takes the other partner to steady them and make them stable. The second column here, all of 2A, remember the families go in vertical columns. 2A is called the alkaline earth metals. One of the most common mistakes that my students make is that they will mix these 2 up, or they'll put alkaline metals and alkali earth. Here's how I remember it. The E's go together. Alkaline ends in E and has the E word with it. So if you write down alkali, there shouldn't be anything else going with it. Alkaline and earth, they go together. All right. This entire group here in the middle, these B's, you see how they have B's beside of their Roman numeral letters? These are called the transition elements, or you could say the transition metals. I don't care. Either is appropriate. All right. Remember from our module 4, lesson 2, when we did the electron configurations? Remember that this little family here came from right here. This breaks apart. If we could cut this, it would right here. I can't make straight lines. If we cut it right here along my blue scribbling, these 2 rows would fit in right there. So lots of times these are referred to as the inner transition metals because they're kind of the little inner group. I'm writing back down here at the corner and it's crappy. I'm sorry. So the inner transition metals. All right. The next 4, they're pretty easy. So this one right here, all of these end in family. It's like you just name them from the first element. So this group right here is called the boron family. Want to take a guess what this one's called? You said it. It's the carbon family. This one is the nitrogen family. This one is the oxygen family. Woohoo! Those are easy. The problem with these 4 families is that they are made up of a mixture of elements. So like the boron family is made up of a metalloid right here at boron, and the rest are metals. The carbon family has a non-metal, 2 metalloids, 2 metals. The nitrogen family has 2 nonmetals, 2 metalloids, a metal. You get the idea. They don't, their properties kind of vary quite a bit because they're made up of so much, so they don't have some special funky name just for those. We're just going to call them by their first element name. Now back to this one, kind of running out of a little bit of space. I may write it down below for that matter. So group 17 here, or group 7A. These are called the halogens. Halogen means salt former. So if you put any of these metals over here with one of these, it's called a halogen. Or sorry, what am I saying? It's called a salt. So if you put like lithium together with fluorine, it would make a salt of lithium and fluorine. If you put sodium and bromine, then it would make sodium bromide, which is a salt. Again, so anything with a halogen makes a salt. This last group right here, those are called the noble gases. And they're called noble because they're snooty. It's like they're stuck up. They don't want anything to do with anybody else on the table. And we're going to talk about that leading into, I guess, not the next module, but the next. We'll kind of learn a little bit more what makes these guys so stuck up and so snooty. But either way, they're all gases, so they're called the noble gases. Okay, one thing that I just happened to think of while I'm doing this, I need to go back to this for just a minute and mention here. I don't know, I was talking about snooty and noble gases, and somehow it hit me that I should mention over here that our good friend hydrogen, who is element number 1, is sitting with a metal family, but hydrogen is a non-metal. It just so happens to be sitting with the metal family because it has the same number of electrons as them and it acts like them. But you do need to know that hydrogen is an oddball out and it's a non-metal that sits over here. Okay, so now it's practice time. I have some practice problems for you about this, about just identifying the families, some practice with that type of stuff. There's a little bit of review with the electron configurations because that has to do with how the table is organized. So I guess get to that and get it turned in, and we'll have our last lesson for this module.